So forming a trans 1,2 diol. And so what we have drawn here is an example of a trans 1,2 diol. So 1,2 because there's alcohols on adjacent carbons, diol because it's two alcohols, and trans tells us that they are pointing in opposite directions. One is pointing away from us and one is sticking out of the plane of the page at us. So how we form a trans 1,2 diol is we do a ring opening of an epoxide. And so if we take an alkene, so if I want to make this 1,2 diol, I would have to start with the alkene between those two carbon atoms. So if we take this and we treat it with a peroxy acid like MCPBA, we will make an epoxide. And then in a second step, we can do something like treat it with aqueous acid, and that will open up the epoxide. So in the first step with MCPBA, we will make an epoxide. And then if we were to treat this epoxide with aqueous acid, the first thing that would happen is we would protonate that epoxide. And that protonation step will help to make the epoxide even more reactive. It'll make those carbon atoms even more electrophilic. And so we'll have this protonated epoxide. And then we have water in here. If we have aqueous acid, we really have quite a lot of water in there, and that is a nucleophile that could open up this epoxide. So I could show it attacking the top or the bottom of this epoxide. And the attack is going to be an SN2 attack, which is how we end up with this trans diol, because this new water molecule is going to approach from the opposite face of where that epoxide is, right? So if this epoxide is sticking up, this new bond is going to be on a dashed bond, right, indicating that it's coming from behind the plane of the page. And so this is a water molecule that attacks, so we have two bonds to hydrogen. And we broke this bond, but that alcohol is still attached to the bottom carbon atom. That carbon atom was not involved, so that chirality will remain. So we'll draw that still on a wedge. And then if we want to get to that final diol product, we just need to use another water molecule. This is a solution of aqueous acid, so there is really a ton of water around. So we can use another water molecule to grab that proton and neutralize this diol. So we will get to the trans diol. Okay. And we could have done that ring opening also under basic conditions. So we could have used hydroxide as well. And you'll still have that SN2 attack, and you'll still get the trans diol as your ultimate product.